Hello again. This is Mr. Kusaj, and we're here for part 2 for lesson 6-2. Okay? Um, so we want to talk about the inverse of a square matrix. Okay? So square matrix means that it has to look like a square. Number of rows and columns has to be the same. So 2 by 2 or 3 by 3 or 4 by 4 or 5 by 5. So we can only find the inverse of a square matrix, and you'll see why in a second. So what is the inverse? The inverse is when you take if you can have two matrices and you multiply them and the answer is the I matrix, and then you multiply them in the other order and you still get the I matrix, then we say those two are inverses of each other. Okay? So, and we can write inverse with that little -1. So what is I? Remember what I is? I is the identity matrix. So when I say the I matrix, the identity matrix, okay, that means it's that one matrix with the ones on the diagonal and 0 everywhere else. Okay, so for example, here are two matrices. They are inverses of each other. How am I supposed to know that? Well, if you multiply them, you'll get the I matrix. And if you multiply them in both directions, you'll get the I matrix. Look, let's multiply A times B, right? This times this. So remember how we do this? Boom, 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 boom. Now with the second row, boom, 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 right? And I did the multiplying, and now I add the answers, right? So -3, 4. There it is. +6, -6. There it is, etc., etc., right? So this is 1, this is 0, this is 0, and this is 1. There you go. I multiply these two, and I got the I matrix. Now check this out. If you multiply them in the other direction, you also get the I matrix again, right? You can confirm yourself. So if you multiply them the other way, B times A, right, you're going to get 1, 0, 0, 1. You're going to get the I matrix. So that means that A and B are inverses of each other. Okay? Finding the inverse, right? Let's go up here for a second. What if I just gave you this inverse and I said, what is the other inverse that would be what is the other matrix that would be the inverse of this? Right? Would you ever guess that it's -3, 2, -2, 1? What is the matrix that would, when you multiply with this, you get the I matrix? What is the inverse of this matrix? Right? Here I gave you two of them. I gave you the inverses of each other. But now I'm going to give you just one, and you find the inverse. How do you do that? Well, the first thing you do is you take the one that's given to you, and you put the I matrix right next to it. So you make this like giant matrix, a double matrix. And you put dots in the middle to like separate them, to know which is which, right? And then you treat it as one giant matrix, and you do row operations on A to get I on the left, right? So the ones and the zeros is on the right. You do row operations, and you end up with ones and zeros on the left. And whatever you have on the right in the end, that is your inverse. Whew. Wow, did you get all that? No? Maybe with the example. So, what is the inverse for this matrix? Right? I want to know what is that other matrix that I can multiply with this to get ones and zeros. I don't know. How can I find out? Well, first, put them side by side. There you go. That's the matrix A, and this is the I matrix, side by side. Now, I want to do row operations, okay, to get 1, 1, 0, 0 here, right? The I is here. I want to get the I matrix over here. Here we go. What's my first row operation here? 3 times row 1 to get 24 there, and 8 times row 2 to get negative 24 there. So I did that because I want a 0 there. So my next one is going to be adding these two, and I'll get a 0 here, which is what I want, right? So on the next one, let me do one at a time. On the next one, first we do row 1 and row 2, and I get what? 24 negative 24 is 0. Negative 15 and 16 is 1. 3 and 0 is 3. 8, 0 and 8 is 8. And you do row 1 divided by 3. So go back to row 1 and just divide it by 3. 24 divided by 3 is 8. Negative 15 divided by 3 is negative 5. 3 divided by 3 is 1. 0 divided by 3 is 0. Okay? So we're moving along. I got the 0 and the 1 here, but now I need a 1 here and a 0 here. Well, I continue up here. Well, if you do 5 times row 2, right? If you do 5 times row 2, you'll end up with a 5 here and add it to the top and you get a 0. So 5 times row 2 and add it to row 1. So here we go. 5 times 0 is 0 plus 8 is 8. 5 times 1 is 5 plus negative 5 is 0. 5 times 3 is 15 plus 1 is 16. 5 times 8 is 40 plus 0 is 40. So I got a 0 there. Almost there. Now I need a 1 here, right? Do you remember our goal? Our goal was to start with matrix and I and end up with I on the left and some matrix on the right. We're almost there. We almost got I on the left. How do we make this a 1? Divide by 8. So if you take the first row and divide by 8, what do you get? 8 divided by 8 is 1. 0 divided by 8 is 0. 16 divided by 8 is 2. 40 divided by 8 is 5. I'm done. This matrix right here is the inverse we were looking for. Right? Because I got the I on the left now. It started on the right. It's on the left. The I matrix. So then 2, 5, 3, 8 is the inverse of A. There's A. This is the inverse of A. Okay? That's one way to get the inverse of a matrix. Okay? There's another way to get the inverse of a matrix, which is quicker, which is a little quicker, but you need to know a separate skill, a separate concept. So let's talk about another concept called the determinant of a 2 by 2 matrix. Okay, what is determinant? Well, let me show you. The determinant of A, and the way we, the notation for determinant, we don't want to write DET all the time. So if you see A with bars, what that's telling you is the determinant of A. That's what it's asking you. The determinant of A, what is it? Well, it has to be 2 by 2, and here's what you do. It's a numerical value. So what you do is you cross multiply A times D, C times B, and then you subtract. Whatever that comes out to be, that's your determinant. For example, see the bars here? So it's asking you to find the determinant of this matrix. What is that? Well, it tells you. Cross multiply and subtract the answers. So 2 times 6, 3 times negative 5. 2 times 6, 3 times negative 5, subtract the answers. This is 12, this is negative 15. So what's 12 minus negative 15? It's 27. Done. I found the determinant. Okay? So what? Well, it turns out that once you have the determinant, you can use it to find the inverse. And here's the formula. So if you want and it only works, again, remember, it only works 2 by 2. If you want the inverse of a matrix, how do you do it? Well, Mr. C, we just did it. You put the I next to it, blah, 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 row operations. No, there's another way. That's the old way. Here's another way. Okay, The inverse is 1 over the determinant multiplied with your matrix. Here's your given matrix. But you don't just multiply it, you got to switch them around a little bit. Okay? So 1 over the determinant. We know how to get the determinant. And then you take these numbers and you do the following with it. See where you get A, D? You switch those two. And these two you leave alone, but take the opposite. Okay? So you're still using these numbers, but you're changing places and changing signs. Change these two places, change these two signs. So here we go. What is the inverse of this? Well, we could do it like we did in the first example, the long way, but now we know a short way. First, find the determinant and put it under 1. What is the determinant of this? Really quick. The determinant of this is 8 minus negative 12. 8 minus negative 12 is 20. So I got the determinant. So it's 1 over 20 outside the matrix. 1 over 20. Now, do I just copy that? No. Switch places. So 2, 4 becomes 4, 2. And you keep the places here, but switch signs. Negative 3, positive 4. Positive 3, negative 4. Right? Just switch the signs. Okay? It becomes opposites. This negative 3 becomes positive 3. Positive 4 becomes negative 4. Now what? Well, you're almost there. Now just multiply this in, and you're done. 1/20th times 4, 1/20th times 3, 1/20th times negative 4, 1/20th times 2. Right? Isn't that the answer? Right? 1/20th times 4 is 4 over 20. 1/20th times 3 is 3 over 20, etc., etc. And then go back and look at your fractions. If they're reducible, go ahead and reduce it. This stays. This can be reduced. Right? 4 over 20 is 1/5. This can be reduced. 4 over 20 is 1/5, but negative. 2 over 20 is 1/10. That's it. Sorry. That's it. I reduced them, and I found my inverse. Okay? So you need to know the determinant. The determinant goes under the 1 on the outside here, and you do some switching of the original matrix, and then multiply it in. Okay? So let me leave you with one try problem. So you can do it just the way we did it with the determinant. Find the inverse of this matrix. Find the inverse of matrix A. That's what that means, right? This means inverse of A. Find the inverse of A if A is 3, 1, 2, negative 1. Okay? All right. See you in class. Bye-bye.